functions now for a while. You pass in a parameter, and then len does some work, and out comes 6, and that goes back into x because the function has a residual value. It just happens to be a built-in function. And so, you know, somewhere deep inside Python there is code that takes this, and somebody wrote a loop or looked something up and then returned a return value and sent back a 6 to go into our x variable. And so a function is there, and like I said, we've been using this for a while. Another thing we tend to do is to look through strings and look at strings and dig data out of strings. Python is excellent for doing sort of these kinds of lookups. And so we can write a simple loop. We can write a for loop that creates some kind of a iteration variable like index. And given that we know that these positions are 0 through 5, we can set this to be 0. And then write a while loop while the iteration variable is less than the length of fruit. And remember, this is 6, so it's going to be 0 through 5. 0 through 5 are the values we want to generate. And then we can look up one at a time, pull out fruit sub index, so fruit sub 0, fruit sub 1, 2, 3, 4, 5, and then print out the position and the letter index, and then add 1 to index, and it runs. This will run 6 times, 0 through 5, and out we go to produce this output right here. And so that's one way of looping through strings. That is a basic indeterminate loop, but we construct carefully an iteration value, and work our way through that loop data. The other way is to use a determinate loop, a for loop. And generally when we are able to use a while loop or a for loop, all else being equal, we generally prefer a for loop. And so here we have the for keyword and fruit, and it's an in. And so for letter in fruit, well, that just says letter is our iteration variable, and it's going to take on the successive values of each of the characters. So this loop is going to run 6 times, and letter is going to be B-A-N-A-N-A, banana. I'm always terrified when I make these slides that I'm going to misspell banana, because somehow I always think that there are 2 N's somewhere. I don't know. It's not one of my favorite words to spell. I actually didn't choose banana as the constant. The author who I borrowed the textbook from, Alan Downey and Jeff Elkner, they used banana, and so I'm still using banana. So some of the jokes in the book aren't my jokes. They are the jokes of Jeff and Alan. So here are just 2 equivalent, you know, so you can have the while loop. They sort of both do the same thing. They both just print the letters out one time through. Each of these loops runs 5 times. But you can see how the determinate loop, the for loop, is a prettier loop, unless you truly somehow need to know this number as you're going through the loop. But if all you're doing is going through and you want to touch in order each of the characters of the string, you then simply write a for loop because it's more elegant. The less code you write, the less chance there is for you to make a mistake. And so the fact that these are equivalent, this is 2 lines of a loop, and this is 4 lines of a loop. That's twice as many places as you could make a mistake, because you might, you know, misspell index or something. I mean, why even make an iteration variable if you don't need to make an iteration variable? And so we can do things that harken back to our iterations and loops chapter, where anything that you can do in those things, like look for the largest letter, look for the smallest letter, search to see if a letter exists, or say count the number of A's in the word banana. And so that's what this is doing. And so we we have a counter. So again, we do something at the top of the loop, we're going to do something in the middle loop, and then we're going to print it out at the bottom. So we start our counter at 0, we're going to loop through all the letters, and then if the letter is A, then count equals count plus 1. This is kind of a pattern in a loop where we're noticing something, and instead of like we did it earlier where we said found equals true, well, we're going to count them this time. So if we have 1, we'll get 1. If we have 0, we get 0. And how many ever there are, but there should be 3 because it's going to run 3 times, and there's 3 A's in banana. And so this is a conditional within count. We've seen counts, we've seen conditionals in loop in prior chapters. And so again, I love the in keyword in Python. It again reminds me of set notation in algebra. If you're a math whiz, if you're not, don't worry about it. Or maybe you will be a math whiz and you'll say, whoa, this set notation reminds me a lot of the the in keyword in Python. So again, it's for iteration variable letter. Again, don't get stuck with letter. I just happen to be using it here in banana. And that is for each character in the string banana. Run this loop once, changing the variable letter to be the particular character that we're pointing at. And so it's taking care, for is taking care of a lot for us, right? And so this is sort of this really smart for loop. The for loop is, you know, both deciding how many times to run the loop, in this case 6, and it's advancing the letter. So advance, print, decide whether you're done, 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 advance, print, decide whether you're done. I am now done because we're done with that particular string. And so you can think of the for as, magically doing all of this for you, of both deciding how long to run the loop, when you're done or not, and moving down through all the successive letters in the loop. So up next we'll talk a little bit about additional things that we can do with strings. So now we're going to dig into strings a bit, and we've already looked at how you can pull out a single character in a string, and now we're going to look at what we call slicing, and that is pulling chunks of a string out. And again, we're going to use the square bracket operator, and so S, and the way I say it is sub, S sub 0 through 4, that's how I read this. S sub 0 through 4. So I look at the colon as through, I look at the brackets as sub. And so S sub 0 through 4 says start at position 0 and then go up through, but not including 4, right? So we don't include 4. So that's probably the hardest part of this. Up to, but not including. Up to, but not including. This seems counterintuitive, kind of like starting at 0 seems counterintuitive, but after a while, you get used to it, and there'll be situations where you're writing code like, oh, that's why that works better. But just for now, remember it. Up to, but not including. It's just kind of a little thing. We'll come back to when that is useful for us. 6 through 7, well, that ends up being starting at 6, up to, but not including 7. So that's why we only get the P out. Now, one thing that Python is pretty nice about is it's not going to give you a traceback. We might expect that 6 through 20, well, there's no 20 characters, but it's like, that's okay. We'll just let you stop at the end, and we'll start at 6 and go all the way to the end. Oh, no traceback. It's almost disappointing sometimes when Python doesn't trace back, when you think, if you're so obsessed about everything, I would have traced back in that situation. But hey, I guess if you're allowed, you're allowed. And so there we go. Now you can eliminate or omit the first or last. If you eliminate the first, it assumes the beginning of string. If you eliminate the second, it assumes the end of the string. And why you would do this, I don't know, but that's from beginning to end, so it's the whole string. So whole string, 8 through the end is thon, and up to but not including 2 is mo. All right, so you get that. So that's pretty simple. Once you've got the rest of slicing and the rest of string indexing, the notion of eliminating the first or the last of the colon expression, the first or second of the colon expression, I think is actually pretty intuitive, pretty nice. We've already been concatenating strings together. We overload the plus operator, and there is no space added. Remember, when you're doing print, x comma y, this comma does turn into a space, but that's not what's happening here. There is no automatic space being added, and so we see hello in there, and it just is hello there with no space. And so if we want, we just have to concatenate the space explicitly if we want to put spaces into strings. The problem is if this, you might think it's more convenient to add a space with a concatenation, but then you have to think, well, what about if I want to concatenate things and not put the space in? Then I'd need a different operator. So that's kind of why it works that way. We can use in differently as a logical operator, so we're using it as an iteration structure in for loops, but we can also use it as an logical operator in if statements. So it's kind of like the, double equals or not equals or less than or equals or something like that. It's like those guys. And so it returns a true or a false. Is N in fruit? So that's a question, and the answer is true. Is M in fruit? No, that's the answer to a question. Is Nan in fruit? Doesn't have to be a single character, can be more than one character, and the answer is true. And then you say something like, if A in fruit. And so this is the logical value that returns a true or a false. And yes, we found it. So that becomes true in this particular case, so it runs the little indented bit. So in is an operator in this particular situation. In a for loop, in means something different. And we'll use in for other things as operators, as logical operators, coming up in a bit. You can compare strings, and this has to do with the character set of your computer, the character set that Python is, but in general, it is lexicographically less than and lexicographically greater than. Uppercase and lowercase are a little weird. I think when we used the max function earlier, the way my computer was set up, uppercase was less than lowercase. But in general, uppercase is less than lowercase. But in general, it's bad to assume case, but there is a deterministic way to sort strings. You can, have something equal to or less than or greater than, and all those operations work naturally. The less than and greater than, you have to kind of be aware of uppercase, lowercase, things like where punctuation sorts less than or greater than letters. That's kind of unpredictable and depends on the character set of your computer, and something you just play with and figure out. If you're doing sorting stuff by first name and last name, as long as the case is kind of the same, if you were sorting Chuck with an uppercase and Glenn, the fact that these uppercases, they'd sort right and these lowercases would sort right, but if you were to subdue instead lowercase Chuck and uppercase Glenn, then that would sort weird. As a matter of fact, the G would come before that. And so case can mess this up. But in general, other than case and special characters and other things, it technically works. It's just hard to kind of predict it. A lot of what we do is use the string library. And so the strings are objects, and we'll talk later about what that really means. And objects have these things we call methods. So a string object has some built-in capabilities, and one of the built-in capabilities that the string object has is, here is a string object, and because greet is a string object, if we said type, we'd see that it was an str. Dot lower says, hey, dear string, make a lowercase version of yourself. It's like calling this function lower and passing greet into it, and then give that back to me. Now it doesn't actually change greet, it gives me a lowercase copy. So here I have hello Bob with an H and a B uppercase, and what I get back in Zap is hello Bob all lowercase. And note that greet is unchanged. So hello Bob is still there, and you can even call these methods on constants. So this is a string object, quote hi there quote, dot lower, that says call lower on this bit of string and give me back a lowercase version of it. And so it prints out as the residual return value. This is like a function call. A method call is a kind of special form of a function call. It's a function call where you say the thing dot the function name rather than function name passed in as a parameter. Like len, for example, is non-object oriented. Len of x, that's non-object oriented. Object oriented would be x dot something, parenthesis. But so constants are objects as well, and taking the lower gives us back lowercase hi there. And so that's just one of the things that you can do in the string library. These are built into string variables and constants. They're just always there. As soon as you make a string, they're part of it. And when you do type and it says it's class str, we'll get to object oriented. Don't worry, we'll get to object oriented. Okay, and so you can do things like use the type. If you're just, look, this used to say type stir, but it's class stir, kind of, this is more of an OO. The word class is an object-oriented concept, but it is a string, and you can use the dir, and of course there's extra stuff up here, and this is showing all the different methods or capabilities, things we can do to strings. So, you know, x dot something, parenthesis. Well, what can we do there? This is all of those things that we can do to x's that are built in and come with x's, come with strings when we build them. And Python, of course, has great documentation online for all of these string methods and what they do and how they work and why they work the way they do. And so here's some of that Python documentation. We'll look at a few of these, but you know, don't hesitate to say Python string uppercase, and then we're like, oh yeah, that is upper, right? And so here's a few things that we can do and use. Some of the ones I use a lot, and we'll look at each one of these things. So the find operation says find me a substring within a string. Right? Find me a substring within a string, so find me the first NA and give me back the position. So that gives me back 2. And then I can say, go find a Z in there. Well, there's no Z, and so it returns me -1. So that's what the find does. So we're going to use this kind of stuff a lot, and we do a lot of looking in strings. Converting things to upper or lower case, there is an upper method and a lower method. So greet.upper. And that means the uppercase NNN is hello Bob. Greet.lower, that means that www is the lowercase hello world. And greet is unchanged. Greet is still hello Bob with upper and lower, because each of these methods basically say, I'm going to give you back a uppercase copy or a lowercase copy of the original thing without changing the original thing. Search and replace is super useful, super duper useful. And it's pretty clean. Here we have a string, and we use the replace method. In this case, we're passing in the old and the new. Bob, replace all Bobs with Janes. And so that takes this hello Bob and turns it to hello Jane. Again, greet is unchanged. Greet is unchanged. And it does more than one thing. So this says go find, well, let's clear that. This says go find all the O's and replace all the O's with X's. And so it goes and finds 2 of them, and then out come 2 X's. And so that really is replace is not just replace the first one, but replace all of them. White space, as we'll see, is a big deal. And white space is not just blanks, although the most common thing, but it's also sort of non-printing characters like tabs and new lines and other kinds of things. And so we have a number of different ways to strip white space. So here we've got some spaces at the beginning and spaces at the end. And we do an L strip, and that throws away the spaces at the beginning. That's the left, so that's a left strip. It all takes any, if there's nothing there, it doesn't harm it. R strip means throw away all the blanks on the far end. And then strip says go take both sides for strip, and so that pulls out all the spaces on both sides. This will be useful because sometimes when you're tearing stuff apart, you'll find yourself getting extra spaces. Sometimes at the beginning, sometimes at the end. And it can be tab or new line. It's sort of white space that is kind of not visible, clear. That's what white space is. It's like if you were on a piece of paper, it's the white space. It's like X. Well, that's not white space, but right here, oh, that's white space. It's any character that doesn't cause printing to happen, if that makes any sense. It's any character where nothing would be printed. And there are characters like that. There's like even bell characters, but we don't use them very much. We can ask very conveniently, we can say, hey, does this line start with a particular string? And so, you know, line, does this is a question, going to return a true or a false. Does this line start with please? And the answer is true, it does start with please. Does this line start with a lowercase p? No, it does not. And so again, you'll use this in the context of if something, colon, some block of text, some block of code. So we can combine these things to tear stuff out. And so let's assume that what we want to do in this case is we want to take a from line. This is from an email format from a mailbox. And this has got the from with a space and the person's email, and then @ sign and the school they're from, and a space, and then the rest of the stuff like when this mail was sent. And this is a real mail message from this guy Stephen from the University of Cape Town in South Africa. And it's really Stephen, and this really is the first line of a file that you'll get to know pretty well by the rest of this course. Hi Stephen, we like you. You are the example in my class and have been for a long time. People actually who know Stephen have taken this class and they're like, Stephen, I saw your picture in the class. So if you're ever in Cape Town at the University of Cape Town, say hi to Stephen and tell him that you saw him in the class. But okay, that's neither here nor there. What I really want to do is I want to extract his school from this email line. Okay, so now eventually we will do things like the data will come from files, but this is still chapter 6. So this is the data we're going to search through. And so we can say, hey, let's go find the @ sign. Search up to this position and find the @ sign. So data.find @ sign. And give me back where that's at. That's in position 21. It's position 0. Then what we're going to do is we're going to look for the next space after the @ sign. So we're going to start at the @ sign and tell find to start here and look forward until it finds a space. So data.find, look for a space starting at the position of the @ sign, and then that'll be in position 31. So 31 is what we get in the space position. So now what we have is we have in two variables, we have position, the position of the @ sign and the position of the space after the @ sign. Now what we really want is this bit right here. So we have to go one beyond the @ sign, and we don't want the space. So we say, we're going to use slicing here, data sub at position +1 up to but not including the space. Oh, smiley face, because we didn't have to say space -1 because that is up to but not including. And so we get that little bit right there. So we don't have to say -1 there, because this is not actually included. The thing that's at the position of the space is not included. So that's already a little benefit for the up to but not including. And so when we print this variable out, host, we get exactly just the school that Stephen works at and probably went to, as a matter of fact. I don't know if he went there or not. So this is just kind of a note for non-Latin character sets. All programming languages from the 60s on tended to work in what we call the Latin character set, which is United States and England and Europe, and lots of places use this ABC character set and the special characters. But it's really common to want to use different characters. And so if you're going from Python 2 to Python 3, and we'll talk about this a little later when it matters more. Luckily, we're in Python 3, and so one of the big things about Python 3 is that all the internal strings are Unicode. In Python 2, there was sort of some confusion as you went between strings, and this is just a little bit of code. And so I'm putting in here, some Asian characters. This is Korean actually. Asian characters into X, and then I say what kind of a thing this is, and that is a string. And then there's this Unicode, and this comes from Python 2. If it's a Unicode operation, it's still a string. Whereas in Python 2, if you put international characters into X, then it was a string, and then there was a separate kind of a constant called a Unicode constant, and it was a different type. And there was ways that you had to mess with these Unicode variables as you did things like read them from files and put them back into files and did other things. So it was much more difficult in Python 2, but we're doing in Python 3, and in Python 3 it natively understands non-Latin character sets, international Asian character sets, Spanish, French character sets. And so this is a good thing for Python 3, and this is one of the real benefits of using Python 3. And as we start doing stuff where we're exchanging data with the outside world, this will come into play, and I'll have to show you how to use it. There was weird things that you had to do. It just makes a lot more sense in Python 3. Okay? So we've talked about strings. We learned about the string. We're converting it. We've done a whole bunch of stuff, and this is again, we're not yet doing anything super useful. We're learning sort of how to like slice and dice, even though we're sort of not making the meal yet. Up next, we're going to talk about files, we're going to read some data, and we're going to slice and dice and use all the things in the next chapter that we've learned up to this point. So see you in a bit. Hello and welcome to Chapter 7. This is the chapter where it all really starts to pay off. We have been learning bits and pieces and doing little 2 lines, 3 lines, 4 lines of code to learn the basic building blocks of Python and learn some of the syntax and define lots of terms. But now we're actually going to start doing something. So if you look at what we've been doing so far, you know, we're inside this little computer, and you type up, the Python says what next, and you give it its command and it does something, and you do something else and does something, and you do this 3 or 4 times, unless you write a loop, and then it goes like 10, 20 times, and that's it. And then maybe we write a thing that reads something from our keyboard, gives us something back, and then we write something that prints something out, print a few things out. And so we've been pretty much using the keyboard, the screen, the CPU, and the memory. That's kind of where we've been living. And while it's important to talk to the keyboard and the screen, the real world is things like databases that live out here, files that live on our systems, and connecting to the network and reading data from the network. And so that's what we're starting to do right now, is we're starting to be able to work outside kind of our code and create things that are permanent. And so we're going to be talking, initially we're going to work on files. We'll later talk to databases and the network and other stuff, but for now we are talking about files. And so really we're stepping out a little bit and reading things that are permanent and creating things that are permanent. The kinds of files that we're going to talk about mostly are text files, and you can think of these as a sequence of lines in a file that are easily read by Python. You've been making text files all along. Your hello.py, that file's a text file too. You're using a text editor to create that file. You put your Python commands in a file, you run those files, and that's what it is. And so a file can be thought of as a bunch of lines, 1, 2, 3, 4, 5, 6, 7, a blank line here. That's possible. And but the reality is that these are actually just lines, and we have a special character called the new line that we'll talk about in a second. So to read a file, you have to call the open function. And open returns what we call a file handle. Open doesn't actually read the file. Open makes it possible so that you can read the file. So the parameters to open are, it takes one parameter that's required, which is the name of the file. Another parameter that's optional, whether or not to read it or write it. If we're reading the file, it doesn't harm it. You can read it over and over. If you write it, if there's already data in that file, it truncates it and writes something. And we're not going to really write files, we're mostly going to read them. And so open you pass it in a file, it gives you back this file handle, and then you have a variable in which you store it. I often call it fhand to be mnemonic. You'll see my code, I use fhand all the time to indicate that that is a file handle. And so if we were to run this in interactive mode, we'll open mbox.txt, and that is a function built into Python, and then it gives us back a handle. It does not give the data. And you can kind of see this when we print out the file handle using the print statement. It doesn't print the lines that are in the file. The lines that are in the file are sort of out there. There could be like 10 million lines for all we know, lines in the file. The handle's like a little opening outside of your program, and you can talk to the file by opening it. Then you can read stuff. If you're writing the file, you can write stuff, and then you close the file to shut the handle down. But handle is a thing that allows you to get to the file. It is not the file itself, and it's not the data in the file. It's just a wrapper that kind of allows you. So this, if you print it out, it's like that's the file we opened, we're reading it, and encoding has to do with the different kinds of character sets, which we talked about at the end of the last lecture, that Unicode character set, etc. UTF-8 is a great character set. It's probably the most typical character set that you will run into, although you can have different character sets of files, but most of them are UTF-8. So, of course, this is Python. If you make a mistake and there's a file that doesn't exist, we get a traceback, and it blows up. We'll show you in a second how to deal with that. Now, the new line character is an important part of file reading. And in files, in strings, we can put the new line character in by this \n character. And the \n is the character that indicates that we're supposed to go to another line. Go to a new line. Go to a new line. And so we have, what is this? Well, that's a \n. That's a \n. And so if we print it out, we print it this way, we see that the \n is in there. This is how we type it. We actually type \n to Python to indicate that we're supposed to put that there. But if we do a print statement, it actually interprets the \n, and so the \n causes kind of this movement to the beginning. Now the print actually, at the end of this, adds another \n. So the \n that we put in by putting it into this string is that one, and then print always puts a \n at the end. There's actually a way to override that \n behavior by putting something on the print statement, which we'll talk about later. Now, it's important to note that the \n is one character, right? And so even though this x\ny prints this, and then print adds another new line to go down to here, if you ask how many characters, what is the length of this? Well, it's only 3. That's because that's a character, the \n's a character, and the y is a character. So it's a 3-character string. So the \n is a character like all the rest of the characters, but it's only, we encode it by typing \n. It's called an escape, where the \ is the escape, \n is a way to say new line, because we can't see it. It's a way for us to encode in a string this non-printable character, this invisible character. The white space, it's part of white space. So as we're reading through the file, we can think of it as a sequence of lines, and we can read these a line at a time. We can also read them a character at a time if we want. And so, but it's more common to say read this line, read the next line, read the line after that, etc., etc., etc. But the way to best think about this, it doesn't really matter. You can think about it as lines, and we will in most of the programs that we write. But realize that the way when we see this, when we see it like this, it comes back to the beginning, it comes back to the beginning. There's a character in the file at each of these points to say go back to the beginning. It's like hitting the enter key on your computer, and that is a new line. So you have to think that in the file, in order for your text editor and Python and everybody to know where the lines end, you put new lines in the file, and that's another character. So, you know, this looks like an empty line. This line here looks like an empty line, but really it has a single character, and the character is a new line. And it turns out that in a bit we're going to need to keep track of the fact that every line is ended by a new line. So up next, I'm going to talk a little bit about how to read files in Python. So we're going to find that there's a number of different ways that we can read through the file, but the most common way that we're going to read through the file is to treat it as a sequence of lines, and we're going to use the determinant loop, the for loop, to do this. And so what happens here is we get back this handle that opens the file and gives us back the handle. That handle x file is the variable I just named it x file. That's not the data, but it is a sequence. It is that file handle represents to Python a sequence that we can potentially walk through and then get all the lines. And it's the simplest, most beautiful, elegant way to read all the lines in a file. We use the for loop, and we have an iteration variable. This is going to take, when we talk about the file, cheese is going to be the first line, then the second line, then the third line, then the fourth line. So it's like going through a string, but you're going through a file now, and you're getting it line by line. So that's each line. I just picked a variable named cheese so you didn't get confused. Later I'll call this line, but Python doesn't know anything special by naming that variable line. Okay, and so this is, it's the for and the in, and so for, I read this as for each line in the file x, the file handle x file. So run this loop one time for every line and then print it out. So it's actually really quite simple. Okay, other languages like C or C++ or other languages, they have to write while loops with end of file conditions and all kinds of things that make this very difficult. But this is one of the prettiest things that Python has. It's a very, very pretty thing. Okay, so let's talk about what we might do. And we're going kind of back to iterations now. What if we wanted to count the number of lines in a file? Well, this is a basic loop counting pattern. So we open the file, and then like in all these loops, we do something to sort of prime the loop to get it started, set a variable count to 0, and I'm going to use the variable line that's going to go through each of the lines in the file, for line in fhand, down the file, and it's going to run this loop once for each line in the file, and the variable line is going to change. But all I'm going to do is add count equals count plus 1, and so that's just like from counters, that's just how you detect. So every time we see a line, we're just going to add 1 to the counter. We're not printing the line, we're not even looking at its data at this point. And then when the line is done, however many times it has to go, out it comes, and we print out line count equals count. And so if we open inbox.txt, this is going to do all this work and then print this line out and say line count is 132,045. So this is a little 5-line program that shows you how to count the lines in a text file using Python. Again, simple and elegant and not too much syntax for you to have to learn. Now it's also possible to read the file as a series of characters, all in one go. Read the whole file in. Now you got to be careful depending on the size of the file. This is going to lead to a string variable with a lot of data in it. Now if it's 100,000 characters, that's actually kind of a small thing. But if it was 10 million lines, that would probably not be good. You'd want to read it one line at a time and process each line and then do something. But mboxshort.txt is a small little file. So we open it and we get back a file object, file handle object, and we call the read method, and that says go through and read all the text and give it back in one big blob, one big string, and I'll put it in imp. And so that's where you have a line, a new line, a line, a new line, a line, a new line. It's not really lines, it's just a sequence of characters with new lines in there to punctuate them. And now you can split that, later we'll see how to split that into separate lines if you want. Now I picked a file that was short, and so this imp variable now has a string in it, and I can use the len function, pass a string into the len function. It says, 94,626 characters. That's kind of a small little file, and perfectly okay to read it all in one go. And so now I say just print the first 20 characters. That's beginning to up to but not including 20, and so it shows the first 20 characters of that little file is a from line, because this is a mailbox file. Now, let's say we're going to do a searching, and we did this loop where you're looking for something. And so we're going to search for lines that have a prefix of from. Okay, that's what we're going to do, and we're going to print those lines out. So there's lots of lines in this file. Line, 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 from. Line, 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 from, right? On and on and on. And we only want to show these lines, the ones that match, right? That's what we want to do. And so we are going to write an open statement, and then we're going to loop through, and we're going to ask the question, if the line starts with from, print it. So sometimes it's going to skip, 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 and then it's going to run it, and then skip, 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 and it's going to run it, skip, 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 and then it's going to run it. Okay? So that's the basic idea, and that'll finish when it's all said and done. And so this is like a criteria. This is like a search. We're looking for lines that match the string, that have the string from as their prefix. Now, when we look at the output of this, it's kind of weird. We see kind of these little blank lines that show up. Blank, 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 blank. What's going on here? What's going on? So let's take a quick look. The problem is new lines. Well, I mentioned that the file has new lines in them. And so when you do the for loop, it doesn't throw the new lines away. As you might expect, it would be kind of nice if it did, but it doesn't. It actually shows you, when you read, it reads that first line up to and including the new line and gives you that back as the variable. So that is the first new line, so that means it's going to go down. And then the print statement actually adds another new line. So that's the second line of the file has a new line at the end of it, and the print statement adds another new line. So if we take a look at the code, there is a new line. Oops, come back. If we take a look at the code, this variable line has a new line in it. Oops, where am I at? I'm in the wrong slide. There we go. Yeah, this is the one I want to do. If we look at the code, there's a new line in here, and then the print adds another new line. So the print adds a separate new line. And that's how we get two new lines. The print statement's new line and the new line from the file. here's how we fix it. And you're going to write this code a lot because when you're reading text files, you end up with a new line, and often you don't want the new line. But thankfully, as we saw in the previous chapter, there is a nice little function in Python for strings called strip that allows you to throw away white space. And to review, remember, white space is anything that doesn't print. And this new line is not a non-printing character. So rstrip gets rid of it. So it's a way to get rid of white space. And rstrip does it from the right end. So it's the right end of the string. And so if we just are going to loop through all the lines in the file, we say line equals line rstrip, and then this variable no longer has the new line at the end of it. We have our little if statement, and if we print it, then this line, the data has no thing, and then the data has a no new line in it, so the print only goes down one. And so now we have single spaced output. And so you're going to be doing that a lot. It's really common to read through a file and then just strip the new line or any trailing space off the end of that. Now, there's a couple of ways to do a loop like this, and let's just think of this as we're looking for a file with lots of different lines in it, and we want to ignore all the lines except some, say, good lines, and we want to do something with those good lines, or the lines we're looking for. Needle in a haystack. This is like searching for a needle in the haystack. So if you look at this code at a high level, we're going to loop through everything, and then we're sort of picking which lines are, and these are the good lines down here. Now often we have a bunch more code that we want to do, and we're not just printing them, but we're going to do a lot of code. So sometimes you actually structure the loop a little bit differently. And so the way to do it, and this is going to do the exact same thing, it's just a little different way of thinking about this loop. So the top part is the same, we're stripping it, and what we're doing here is everything's the same here except we add this not. If the line does not start with from, that's the translation of that. If the line does not start with from, continue. So basically we have a skipping pattern. So the lines we're not interested in, we skip. So we come down, we skip a lot of lines. And then we find a line that's good, and then we fall through. So this is the good code, and then we have all the other good code that we want to do to that line. We have that showing up down here. And so there's just two patterns, two ways to do the exact same thing. So another way to select the lines that we're interested in is to use the in operator. So we talked before about the in operator and how that works. So we're basically going to use the continue skipping method. So we're going to read all the lines, these first few lines. If uct.ac.za is not in the line, skip it. And so this is going to print out all the lines that have the string uct.ac.za in them. And so you see this is the output of the program, ... Sometimes you'll have programs that want to read different files. Often I give assignments where I say, show me how this program runs on the short file, and then show me again how it runs on the long file, just like this. And so the way we do that, to input the file name, instead of making the file name be a constant to the open call, we make the file name be a input. So we just run an input statement, which gives us a prompt, and then we type mbox.txt, and then that shows up in this variable f name. It's of course a string all the time, and we pass that into open, and then we open it, and then we do the count operation. So if we enter mbox.txt, it counts 1797 subject lines in mbox, and if we give it mbox short, it says there are 27 subject lines in mbox. And again, this is another one of those ifs, and it's just counting, but only counting lines that match a particular pattern. Okay, so now the user can also type bad file names, and we need to be able to deal with that as well. And so we're taking a small change to the code. The dangerous code is this line right here. This line right here is going to trace back if that file doesn't exist. So what do? Well, we're going to just expand that. The rest of this program is exactly the same. The only thing's different is we've got this line. We took out insurance on it, and we know that it might blow up, and so we have it in a try and except block. So here's how the code runs. So, the input runs, we type in a good file name, it comes in here. This works, and so it skips the except, and so it runs the code and prints out the count. So that's the good pattern. The bad pattern is here, where we type in a bad file name, it comes in the try except, this file name is nanaboo, and it's going to blow up. So this line blows up, so it jumps down into the accept code, prints out, file cannot be opened. So it prints this out. Now this quit is really important, because if we don't put this quit in here, it's going to continue down here, and that's going to blow up here because file handle is not defined properly at this point. And so what we have is we have this quit. Quit is a special function where it comes in and never returns. So this is a way to terminate the entire Python program silently with no traceback. All right, so we put in our own error message, so we look like we're professional, say, oh, could not open this file, and then we stop. If you don't, it's going to come down here and it's going to trace back right there. It's going to blow up. So the quit is useful when you want to stop executing because you've detected some kind of an error. So that's a quick zoom through opening and reading through files and doing some patterns. Most of the rest of the programs in this course are going to say open for rstrip, look for, and then do something interesting. That's going to be our loop that we're going to do over and over and over again. And now we see how this looping and if and iteration and variables are starting to come together, and you can actually sort of do a program that does something useful. But before we get to too many more programs, we got to switch a little bit, switch gears, and talk up next about data structures, and that is the shape of data. And how we can use more intricate and complex variables to help solve our problems. Hello and welcome to Chapter 8. We're going to talk about lists in this chapter. Up to now we've been talking about algorithms. Algorithms are the concept in computer science of using the programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or open a file, read everything. If the first line starts with something, do something. If not, skip it, and then add all the things up. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out the data and clever ways that you make sure that the data does what you want it to do. And so that's what we're going to start talking about now. Lists are the first and the simplest data structure. Strings are kind of like data structures, but lists are probably our first real data structure that we're going to think about and design and make use of effectively. But before we talk about what is a collection, we should talk about what is not a collection. So we're familiar with what a variable is. We know that a variable is a little piece of memory that's got a label on it. And then an assignment statement, sticks a 2 into X, and then and then 2 is in this little cupboard. And then it goes to the next line, and then 4 goes into X, and so the 2 goes away and the 4 is there. Now, a key thing is you can't have more than one variable at any given moment, right? And more than one value in a variable. So when we move to collections, collections are more like suitcases. We can put lots of things in them. We have ways of organizing them, and as we go through lists and dictionaries and tuples, we'll see how there are different ways to organize them. And as a matter of fact, we've been talking about lists for a while. Every time we use one of these square bracket syntaxes in earlier programs, we've been working with lists. And so this is technically a 3-item list with 3 strings, got commas here. Joseph is one string, Glenn and Sally are another string. And here's another one that is another thing. And the list is basically, it's a list constant and it's being assigned into a variable. So this friends variable has 3 things in it. So that's different than what we've been talking about before. So these bracket structures with square brackets are those lists. And so the print is just a print with parentheses to get the print to work. But 12476 is a 3-item integer list. Red, yellow, and blue is a 3-item string list. But it doesn't all have to be integers or strings. Python can handle different things and different kinds of data in different positions in the list. So red, 2498.6, a 3-item list with a string, an integer, and a floating point number. And while we're not going to use this too much for now, this outer list is a 3-item list, and the second item is another list. So this is kind of alluding toward what we'll do when we start talking about data structures, and that is we have a structure and then we have another structure inside of it, and sometimes this can get quite complex. And we're doing this for a reason. This here has no reason, just to show you that it's possible that lists can be made up of lots of things, including other lists. And of course there is also the notion of the empty list. And like I said, I have had to be able to tell you about lists all along. We use them in for loops. We can put lots of things here. We can put file handle here, we can go through the file, we can put a string there, we can go through the characters in the string, and then a list. And the iteration variable then goes through the successive elements of the list, and that's why this prints off y4, 3, 2, 1, and then the loop is done and it prints out blast off. So we've been using them, and we've been actually iterating through lists with for statements all along. So the for statement, has been something we use with lists, and when you just need to go iterate through the list and go through every item in order, the for is a great way to do that. So friend is our iteration variable, friends is our list variable, and so that says friend is going to successfully take on the value Joseph, Glenn, and Sally and print out, Happy New Year, Joseph, Glenn, and Sally. It runs 3 times, once for each of the values, and the iteration variable advances. Now, I do want to make it really clear that the choice of friends and friend singular and plural is arbitrary and capricious. It happens to be convenient and intuitive that the iteration variable is 1 and the list variable is more than 1. But Python has no idea about singular and plural. As a matter of fact, Python would care. It would be totally equivalent for Python to do the same thing, to have the list variable be z and the iteration variable be x. X will take on the successive values of these 3 things. Now, am I being nice to you by calling this list friends and this iteration variable friend? I am, but I also don't want it to confuse you if you're just a beginning developer. So, just like strings, we can sort of look within lists. Part of the thing is when you put more than one thing in a data structure, you need to get them out. And so lists have positions, they maintain order, and so the first thing in the list is the sub-0 position, sub-1, sub-2. Just like strings, they're zero-based, just like European elevators, they're zero-based. So if we take a look and we say, oh, friend sub-1, that's how I read that, the little square brackets, when you take a variable here and you say friend sub-1. Remember, singular and plural don't matter. Friend sub-1 means Glenn, because this is the 0 and that's the 1, and then Sally's the sub-2, and so that's what prints Glenn out in this particular thing. Now, lists are mutable. Mutable is another word for changeable. They can be changed, meaning that a list has 3 things. You can change the thing right in the middle if you want. To take a look at what's not mutable, strings are not mutable. So if I take a look at assigning banana into fruit, well, fruit sub-0 is a capital letter B. Could we imagine for the moment that we could change fruit sub-0 to lowercase b? Well, the syntax would be how you would do it if you could do it, but it turns out that strings are not mutable, meaning they're not changeable once you create them. And that's why when we do things like lowercase or uppercase, we take a look at the fruit and we say, give me a lowercase copy of that, and then we take the return value from this and we store that in x, and that's how x becomes a lowercase banana. But fruit is still the original one, so fruit has not changed. Compare and contrast that with a list though. Here we have a 5-item list, 2, 14, 26, 41, and we're going to do the sub-2 position, and the sub-2 is 0, 1, 2, so that's that one right there, and we're going to assign a 28 into it. So that 28 is going in here, going to wipe that out and put 28 in. So we can do item assignment in lists by putting a bracket syntax on the left-hand side to say, don't just put it in the variable, put it in this position within the variable. So that's what that's doing, and when you print that out, the 28. Everything else is unchanged, meaning the whole list is there. There could be 1,000 items in the list, and then you're changing the second one. We have a function called len. We've been using this len function all along to take a look at how long strings are. It counts the number of characters in the string, so that's a 9-character string. If we have items in a list, len tells us how many items there are. It's not like how many characters there are, it's the number of things. And each thing doesn't have to be a number. It could be a number, a string, or even another list. And len is the way to say, hey, how many things are in there? There's a function that returns a list of numbers, and we use it, as we'll see in a second, to construct specialized loops to go through lists. So let's take a look at this range function just for a minute. So range takes as its parameter the number of numbers that you want returned, So I'd like a 4-item list with the numbers 0 up to but not including 4. And so it just turns out that that is really useful for constructing for loops that are counted for loops that go to 0 to the 1 to the 2, as compared to the the definite loops that go each way, go through each one. And so it's a common thing to say, okay, we know how many things are in this list. There are 3 friends, and if I combine range and len, so I take len friends, which is 3, and then I take range sub 3, I get 0, 1, and 2. And so the interesting thing is this 0 corresponds to the first one, 1 corresponds to the second one, and 2 corresponds to the third one. Okay? And so we'll use this to construct loops, especially when we need to go through an array and remember what position we're at. And so here's just an example of 2 different loops. This is a for loop that's just going to go through whatever's in this list. So friend is just going to take on the successive values, and so it's going to print out these 3 things just as you would expect. And if you don't need to, while you're going through the loop, know the position, your relative position from the top in the loop, that's okay. But sometimes you want a little more sophisticated loop, and instead you want to be able to loop through where you know the position. And so what we do instead is, instead of looping through the list itself, we do range len friends, which gives us 0, 1, 2. And then I takes on the successive values 0, 1, and then 2. So this loop is going to run 4 times, and I is 0 the first time. And we might even just look up the value inside that sub-0 value, so we get Joseph the first time, so prints out Happy New Year Joseph, goes, and I becomes 1 now, and so it gives us Glenn, and that prints out, and away you go. So if you look at these 2 loops, they really do the exact same thing. The only difference is this we allowed the 4 to find its way with the iteration variable through, and here we created our own I variable that went through the positions, and they're dense, there's no gaps in here, so it's 0 through 2 that it goes through. So these 2 are equivalent. There will be times when you'll want to use one in the other. I tend to prefer the first one because it's prettier as long as it works for me. So that gets us started with loops. We'll be back in just a bit. Okay, so we've taken a look at loops, and now we're going to just take a bit of a look at some of the operations that you can do with loops. Python has this, as we'll soon learn, object-oriented approach to its operators, and the plus can add strings and it can add numbers. It can add floating point numbers, integer numbers, strings, etc. And so the plus similarly works this way with lists. The plus looks to its left and looks to its right and says, what am I adding? And in the case that I'm adding the list 1, 2, 3 and the list 4, 5, 6, it concatenates them together. In this way, it sort of functions like a string, and so we get 1, 2, 3, 4, 5, 6. It's just concatenate this list to another list. And it doesn't change A or B, just like in any kind of assignment statement. Calculations on the right side don't change the variables, and they produce a new variable and then assign that into C. You can also use list slicing, and it's easy to remember. If you remember how strings work, list works exactly the same way. So it's, of course it's a little tricky. The first number is the starting position. They start at 0. So 1 is right there. So it's the 0 position, the 1 position. Start at 1, right? But go up to, but not including 3. There's 1, 2, 3. So this goes up to, but not including 3. And that's why we get 4112 out of that. So up to but not including. I'll just say that over and over and over again. If we do, you can leave the first part out. You can leave the first part out here, and you can say, oh, up to but not including 4. So that starts at the beginning, goes up to but not including 4. And so that's how we get that piece right there. We can say start at the position 3, 0, 1, 2, 3. Start at position 3 and go to the end. Now the fact that the number 3 is in here is sort of irrelevant. 3 to the end is those 3 numbers. And then you can do the whole list with slicing as well. Again, these pretty much are the exact same examples I used when I was doing strings. They're pretty much the same. There's a number of different methods, and you can look up all the documentation in list. I often just use the dir command to remind myself of them. Append we'll look at. Count looks for certain values in the list. Extend adds things to the end of the list. Index looks things up in the list. Insert allows the list to sort of be expanded in the middle. Pop pulls things off the top. Remove removes an item in the middle. Reverse flips the order of them, and sort puts them sorted order based on the values. So let's look at a couple of these. So if we build a list from scratch, we have a way to ask for an empty list. There are a couple of different ways to ask for an empty list. We could use just 2 square brackets next to each other, but this is a form we call the constructor form, where we say, hey Python, make a list. In this case, the word list is like a reserved word to Python. It's really a reserved class, but